Hey class, Mrs. Anderson. 7.4b, parabolas and writing equations. So these are graphing parabolas that are centered or have a vertex of HK. So instead of centered at the origin. So here's some vocab and some reminders about a parabola and the pieces that we're going to use. A parabola is a set of all points that are equidistant from the directrix and the focus. It's centered at the vertex. You have the axis of symmetry. The directrix is always perpendicular to the axis of symmetry. And then from the vertex to the focus point is P, and then from the vertex to the directrix is also your P. So remember that P plays a big part into solving and graphing it. If it is y equals, and it's positive 1 over 4p, then it opens up. So here's a y equals, so notice it's y minus k equals 1 over 4p, and then x minus h squared. So that one opens up, and the center would be at 0, 0. Versus if it's y minus k equals negative 1 over 4p, then it opens down. If it's x equals and it's positive, then it opens up. And notice that the h still stays with the x and the k stays with the y. And then if it is negative and x equals, then it opens to the left. So right and left there. All right, so let's just do a couple examples. So this one opens up because it's y equals, and the 1/8 out in front is positive. And then your vertex will be at negative 2, 5. So I get that from my HK values right there. The H is always with the X, Y is with, 5 is with the Y. Then to find the focus and directrix, you need to find the P value. So I take the A value essentially, and I set that over equal to 1 over 4P. So if 1 over 4p equals 1/8, then p will equal 2. So start by graphing your vertex at negative 2, 5. And p equals 2, it opens up. So your focus will be 2 above the vertex, and the directrix will be 2 below. So the focus point will be negative 2, 7. I'm changing the y coordinate because I went y up 2, and then the directrix goes through the y-axis, so it's y equals, and it's at 3. So I went from the vertex down 2, so now you're at 3. Then to graph this, I have a total distance here between the focus and the directrix of 4. So from the focus, I'm going to go to the right 4, and from the focus, I'm going to go to the left 4. And then I'm going to connect from the vertex through those 2 points so that the distance from the focus to the directrix is always the same as the distance from the focus to the parabola. So these distances are always congruent or equal. So it's always 4 here and then 4 there. They're always equal. So you find the distance between the focus and the directrix, and that's how far it is from the focus on either side. So there's my parabola. And that's it for that one. Okay, so this one is x equals, and it's positive. So this one will open to the right. It has a vertex of 2, 6. So h is with the x and k is with the y. To find my p value, I'm going to do 1 over 4p, and in this case, the a value essentially is 4. So 1 over 4p equals 4. Solve for p, you're going to have to cross multiply, which means you'll have to put the 4 over the 1. Multiply across. The cross products are equal when you cross multiply. So 4p times 4 is 16p, and 1 times 1 is 1. Then finish solving for p by dividing both sides by 16, so p equals 1/16. Since p is an extremely small value, it's going to be very, very narrow parabola. The A value is 4, so it's very, very narrow. And we're going to have to approximate on our graph a little bit. So if I start with my vertex at 2, 6, and then I'm going to graph the focus to the right, 1, 6, so like very close. And then the directrix back 1, 6, very close. So I zoomed in a little bit and just kind of essentially approximating the best I can. Which means when I draw it, you know, it's only 2/16 apart. So it's just going to be a really narrow parabola there. I might have even got too wide on that last one. But we'll just do the best I can to make it narrow. And the focus is in the middle, the directrix is behind it. So for the ordered pair for the focus, I was at 2, 6, and I moved to the right, so I changed the x coordinate and I went over 1, 6. So really it's like 2 and 1/16, not 6, 1/16, and 6. And then for the directrix, I was at 2, and I went back a 16th. So the directrix is at 1 and 15/16, and it goes through the x-axis, so it's x equals 1 and 15/16. You could put that in a improper fraction instead, like 33/16 and 31/16 if you'd prefer improper instead of mixed numbers. All right, that's it for example 2 though. So very narrow there. We did our best to kind of sketch the graph. So example 3 is writing an equation. To write the equation of the parabola with a vertex of 1, -2, x-intercept of 3, and it opens to the right. So since it opens to the right, the equation is going to be x minus h, and then it's going to be positive 1 over 4p, and then y minus k squared. So first I can start by plugging in my vertex of 1, -2, so that gives me my hk. So it'll be x minus 1 equals 1 over 4p, and then y minus -2 is y plus 2 squared. I have a vertex of 1, -2 and a y-intercept of 3. So my parabola looks something like this. Unfortunately, I don't know what my focus is, nor do I know my directrix, so I don't know what my p-value is, which means I need to use the other information that was given to solve for p. The only other piece of information that I gave you was the point x-intercept. Well, that's the point 3, 0, which means that's an ordered pair x, y. So I can plug x and y into my equation over here and solve for p. So x is 3, and then 1 over 4p, and then plug in 0 for y. And really, I don't even need to solve for p because I'm not asking you to graph it. Really, I need to solve for 1 over 4p for this one. So 3 minus 2 is 1, and then I get 1 over 4p. 0 plus 2 is 2. 2 squared is 4. So then I have 1 equals 1 over 4p times 4. Which means that, oops, I think I did something wrong here. I think I accidentally changed this to a 3 minus 2 when it should have been just 3 minus 1, x minus 1. So this should be 2 here. Okay, so since I want to essentially solve for this 1 over 4p, so I could multiply this out, but I want to leave 1 over 4p by itself. So I'm actually just going to divide both sides by 4 to get rid of that 4. So divide by 4 on this side, and then I get 1/2 equals 1 over 4p. So 1/2 is essentially like your a value. 1 over 4p is your leading coefficient, your a value. So 1 over 4p equals 1/2. So I'm put that back into my equation. So your final answer would be x minus 1 equals 1/2, and then y plus 2 squared. Okay, An engineer is designing a flashlight using a parabolic reflecting mirror and a light source. The casting has a diameter of 6 inches and a depth of 4 inches. What is the equation of the parabola used to shape the mirror, and at what point should the light source be placed relative to the mirror's vertex? So to do this, I'm going to put my x-axis and my y-axis right here in the center. So I'm going to say my vertex is at 0, 0. Then the parabola is being formed on the outside here. Right there. And it looks like you have the vertex right here, 0, 0, and then this little light element, that's the light source. Okay, that's that point right there. So since I drew the axis at the vertex at 0, 0, and it opens up, the equation I need is y equals 1 over 4p x squared. So unfortunately, with the given information, I'm not able to solve for p because p is the distance from the vertex to the focus, and I don't know how far that is. So the other information is given is like this point right here. Since I know that it's 6 units across, I know that halfway would be 3. So this point would be like over 3 up 4. So that's the ordered pair 3, 4. So I can use 3, 4 as x, y, plug it into my equation, and solve for 1 over 4p. So 4 equals 1 over 4p times 3 squared. So that's going to be 4 equals 1 over 4p times 9. I want to solve for 1 over 4p, so divide by 9 on both sides, and I'm going to get 4/9 equals 1 over 4p. So 4/9 goes into your equation. So y equals 1 over 4p, 1 over 4p equals 4/9, so y equals 4/9 x squared. So that was the first question. Write an equation. What is the equation used to shape the mirror? Second question, at what point should the light source be placed relative to the mirror's vertex? So how far should this the point that this light piece should be at, the little light filament? So essentially that's the focus point. They're asking you to solve for the focus. So how far is that from the vertex means you need to solve for p. So if I go back down to 4/9 equals 1 over 4p, I can cross multiply. 4 times 4p is 16p, and 1 times 9 is 9. Then finish solving for p by dividing both sides by 16. I get p equals 9 over 16. P equals 9 over 16. That means that I'd go up from the vertex 9/16 to the focus, which would give me that point would be 0 and 9/16. So that is the point at which the light source should be placed in order to get that reflection for the light there. Okay, that's parabolas. See you guys later. Thanks for watching.